morning, everyone. Three scientific insights that have recently come to the fore change everything. And they culminate into an urgent need of action this super year for people and planet 2015. It's a super year because heads of state meet 3 times to chart the course of the future of humanity. On finance in Addis in July, in September in New York to lock the Sustainable Development Goals, and the Climate Summit in December. It is not only an extraordinary year, it's also perhaps the last chance we have to really have a chance of a sustainable future on a stable and resilient planet, because science shows that the next 5-10 years are decisive because we may be pushing on buttons on irreversible changes. And because heads of state only meet every 5th year or so on environment and climate, it is truly a very, very important year. And these 3 key insights are as follows. The first one is that science welcomes humanity to the Anthropocene. We've become a geological force of change at the planetary scale. In fact, we must, as business leaders, as communities, simply recognize that we're navigating what we today call a 369 world. We're on an average pathway towards at least 3 degrees warming this century, a place we haven't been for the past 4 million years. We're in the 6th mass extinction of species, the first caused by another species, and this undermines the resilience of the biosphere and its capacity for a stable climate. And we're committed to 9 billion people, at least, by 2050, all with the same right to development. The evidence behind this dramatic insight that we have now become a planetary force of change does not come from models or theory. It comes from these kind of observations. The hockey stick patterns which we've become so familiar with when it comes to pressures on the planet. And what you see is the upper left-hand corner here is the classical carbon dioxide hockey stick. But you can pick any parameter that really matters for business or our well-being. It looks the same, from biodiversity loss, ocean acidification, deforestation, eutrophication, overuse of rare earth metals. They have this pattern of very limited impact from the Industrial Revolution 250 years ago up until the mid-1950s, and that's where we have the takeoff point. 10 years after the Second World War, we're 3 billion people, and we put in the high gear of what has been called the moment of the great acceleration of the human enterprise. Things go well. The unsustainable economic growth model based on GDP actually delivered beautifully despite moving right into this acceleration. Up until the late 1980s, we deliver on economic growth in a remarkable way. In fact, we've never seen such success ever before. The world economy grows 5 times. We have people moving out of poverty. We have better life expectancies. Everything that we have nurtured and really, really benefited from occurs in this period. Why? The planet is subsidizing us. There's ample space in the atmosphere. There's ample biodiversity and fish in the oceans. There's enough forests so we can cut them down without having invoices coming back to the Earth system. 1990 is the break point. That's where we start seeing for the first time things collapsing abruptly. Cod fisheries collapse outside of Newfoundland. The Baltic Sea tips over into its algal bloom anoxic state that we so much, on the right side of this country are so frustrated by. Of course, this is a beautiful part of the country as well, particularly now with the Volvo Ocean Race. But from 1990 onwards, we start seeing these abrupt changing costing to the economy. And this is a really key insight, that from 1990 onwards, we filled up the atmospheric space, we filled up the planetary space. We are, as science now can conclude, which I find so dramatic, humanity can disrupt the Earth system's stability, and we have reached a saturation point where we're hitting the ceiling of the biophysical capacity to support humanity. That's insight number 1. Insight number 2, which really puts a humble dimension to this, which, by the way, is a core part of Pope Francis' encyclica, which came out a couple of days ago, which is that humanity is not only threatening creation, we know the desired state of creation. And that is our Eden, which is the equilibrium and stable state that has kept the planet stable for the past 12,000 years when we left the last ice age, which we learned in school to call the Holocene. And the proof comes from this graph. This is ice core data over the northern hemisphere. It's the last 100,000 years. It's a good period to observe because we've been modern humans during the last 150,000 years. So we've had the same intellectual and, let's say, physical capacity to develop civilizations. On the y-axis, you have temperature variability, a good proxy of how it was to live on Earth. And it was a jumpy ride indeed. In fact, we were hunters and gatherers during this period. We were down to a few million people on Earth. You have a cold point here where sea levels were 70 meters lower than today. And we were, can you believe it, according to the latest DNA-based analysis, down to less than 10,000 fertile adults on Earth. We were virtually extinct. We were hiding in the Ethiopian highlands, the only place where there was some food and water to keep us alive. And we were having, to put it very simple, a rough time. Until we leave the last ice age and go into this remarkably, not to say miraculously stable Eden period, the Holocene, which is a plus minus 1 degree Celsius stable state where everything that we depend on establishes itself. In fact, the proof is clear that this is the case because we barely enter the Holocene, and what do? Well, we invent the most important part of modern civilizations of all. We invent agriculture. We do it in 4 different places simultaneously on the planet, which is a proof, because we didn't have smartphones and emailing and stuff, that it was the conditions, the stable conditions on Earth that enabled us to take this step. Because these systems became stable. The marine systems of the coral reefs in the tropical regions, the boreal temperate forests with their predictable seasons. You suddenly had 100 days of above 15 degrees Celsius temperature to grow food. All the forest biomes established themselves. The permanent ice sheets established themselves with the polar region in the Arctic and Antarctica. Everything that we nurture, love, and depend on economically for our own well-being establishes itself in the Holocene. So that's insight number 2. The Holocene is the only state we know that can support the modern world as we know it. You start seeing the drama here. We're in the Anthropocene. We are fiddling with the entire planet, but we need to return to the Holocene. Now, what makes this even more dramatic is the third insight, because we're punching the planet, the exponential rise of pressure. We need to stay in a Holocene. But how does the Earth system respond to our punches? Well, unfortunately, not as we've always believed. In fact, we've built our entire business and economic logic on the assumption that the planet is this big, stable thing that we can even unsustainably exploit without having surprise coming back. But we now know that tipping points is rather the universal response of the Earth system, meaning that over long periods of time we can actually exploit resources with limited impacts, but then with a little extra trigger when the system has lost its resilience, from lakes to forests to wetlands to big glacial systems, the system can tip over a threshold and abruptly and irreversibly change. Now I'll show you a few examples of this for climate. This is back to the ice core data I showed earlier. So you have the last 20,000 years here, so it's the last period of that Holocene picture I showed earlier. You see ourselves leaving the ice age here, so you have minus 4 degrees. We leave the ice age. We come into the Holocene, so here you have the Holocene period. You see the narrow band of plus minus 1 degree Celsius, our Eden. And here you see how we're moving out of Eden in the period that we have since the fossil industrial era begins. Now look at that period and we'll just click it over. Actually, I'll pass this one. I'll go right into this graph here. We click it over and here you have the same graph again, the last 20,000 years. And here you have our 2-degree target, the one that we've agreed upon we should not exceed. And this is unpublished data on the tipping points we, according to science, are at risk of hitting. So what you find is that when we start approaching something around 1.5 to 2 degrees, tropical coral reefs are bound to tip over. The Arctic summer sea ice will disappear at around 2 degrees or so. Alpine glaciers, Greenland in fact, has an uncertainty range between 1.5 and 4, where we might have irreversible melting of the Greenland ice sheet, which leads to another 7-meter sea level rise. The Amazon is feared to be at risk at 4 degrees, the place we're heading during this century, and so on and so forth, up until, in fact, the worst case scenario of losing large parts of the East Antarctic ice shelf. What these are Earth system stop signs. And we seem to now progress as if they didn't exist and simply run them over one after the other. And it just shows that even 2 degrees is a very risky target indeed. In fact, we've suggested that the target should be slightly lower at 1.5 degrees. But it's just to show that tipping points are an integral part of the Earth system. We can even map them today, the big systems that are at risk of abruptly shifting. For example, that the Amazon rainforest, would, under pressures of climate change and deforestation, construction at large, in fact, tip over abruptly and turn into a savanna, releasing massive amounts of greenhouse gases. So these are the three new insights. We're in the Anthropocene, putting pressures we've never seen before. It's just over the past 25 years. We need to remain in a Holocene state. It's our Eden. And tipping points are actually an integral universal part of how the Earth system operates. If you add these three up, you naturally come to the conclusion that we need a new paradigm. We need a mind shift. We need a completely new relationship between the world and the Earth. We've always operated as if we are a small world on a big planet. Now we need to recognize that we're a big planet, a big world on a small planet, and that requires returning to a logic where we have development within a safe operating space. That led science to introduce what we call planetary boundaries, setting the boundaries of the biophysical ceiling within which we can have a stable Holocene-like planet. This has been published in a whole series of scientific papers over the past 5-6 years. The latest update came out as recently as just a few months back in 2015. And what is reassuring is that we're now able, from science, based on our understanding of how the planet operates, to define the big systems that regulate the ability of the planet to remain in a desired state. And of course, these include, not surprisingly, climate change, but they also have a stable ocean and the protective stratospheric ozone layer. But perhaps more surprisingly and equally relevant for construction are what we call the slow variables, or those that operate under the hood of the Earth system, that regulate and sort of say takes the knocks of different stresses, including the large nitrogen phosphorus cycle, the ones that operate basically modern agriculture, global freshwater use, land use change, predominantly forests, and perhaps the most important one, biodiversity, that we have living species across land and marine systems. Finally, we have two boundaries which are totally man-made. We call them, just for simplicity, the alien ones, the ones that are totally alien to the Earth system, which includes chemicals invented by humans and also the air pollution created by our construction, combustion, modern industrial societies. These 9 we concluded in 2009 and suggested if we can operate those within safe boundaries, we can actually have a good future for humanity. This was assessed in 2009, giving us a safe operating space in green, and the conclusion was we were on a danger point for 3 of them, for climate change, for biodiversity, and for nitrogen. The 2015 update looks like this. So one, which is very reassuring for a scientist, after thousands of different critical assessments, we have over 100 scientific papers scrutinizing this work, we conclude that the 9 hold. In fact, we conclude that we've probably got the 9 boundaries right. We've improved the quantifications for all of them, still struggling on chemicals and air pollution, but unfortunately concluding that we are in a danger zone not only on climate, biodiversity, and nitrogen, but also on phosphorus and land use change. So as you see here, 4 of the 9 boundaries are actually in a danger point, and we need to work very actively to transform ourselves back into a safe operating space. What this also suggests is that we have to, every community, every city, every nation, every business needs to operate sustainably at its own scale, but also relate to the planetary scale. We need to all become planetary stewards. That sounds utopian potentially, but we've actually done it once before. Because you see here that the stratospheric ozone layer is in a safe operating space. But in 1980s, when we observed the depletion of the stratospheric ozone layer because of our emission of chlorofluorocarbons from our cooling and heating systems, we were actually out in the red. But we listened to science, we had the innovative industry, we actually had citizens able and willing to deeply change behaviors, and we transitioned back into a safe operating space. We've done it before on ozone, and we could do it again. Now, what's then the status on the climate challenge? Well, the climate boundary is transgressed. We're deep into the red, and we need to return. We have evidence that that is actually causing abrupt change already today. The first I just want to emphasize is that this is the temperature curve. Do not ever sort of say, hesitate on the fact that the world is warming, and the IPCC concludes very clearly that humans are the dominant cause of that warming. What you see here is the absolute latest update, including 2014, which, by the way, is the warmest year on record. So never believe the skeptic myth that warming has halted or even stalled over the past 15 years. That's a statistical trick. If you take the El Nino 1998 year, which is shown here, which was an exceptionally warm year because of the combination of human-induced climate change and El Nino, and if you drew a line from that point, it could appear as if it has kind of slowed off in pace. But look at the overall trend, and 2014 is the warmest year on record, and 2015 has an El Nino in the pipeline. And I just want to flag that 2015 could actually become a very warm year. Recent work just coming out 2 or 3 weeks back, moreover, confirms again that the warming actually is probably more fast even than what the IPCC has stated, depending on the uncertainties in how we measure weather and climate, in particular the polar regions. But the most important is this. Now, you see, we are on average following a path that will take us to 4 degrees warming by the end of this century. That's a very, very dramatic future if we do not bend the curve on emission. But you see, that's only the average. What is the risk of, let's say, a catastrophic outcome, which has a low probability, but an impact that we would never accept? And this graph shows from the IPCC how that risk assessment plays out. And you who are in business generally understand risk very, very well. We are today at 450 ppm. 2015, 23rd of June, we've reached 450 ppm. That's in fact the concentration of greenhouse gases for all gases that we normally have always considered to be the ceiling beyond which we should not go. Now, what this graph shows is the probability at 450 ppm of reaching different average temperature levels on Earth. And let's focus on this level here, 6 degrees. I choose 6 degrees because it's so obviously unwanted. Even a climate denialist would agree that 6 degrees is a place we do not want to be in. In fact, I would argue there's universal understanding that 6 degrees is a catastrophic outcome. It's a place that could not support humanity on Earth. What's the probability at current concentration of greenhouse gases that we reach 6 degrees? According to the IPCC, it's 1.6%. Now, what does 1.6% as a probability of a catastrophic outcome mean? Well, it would be the equivalent of us accepting 1,300 fatal aircraft crashes every day. So it's a risk level that we, in any other part of society, would never, ever accept. But for climate change, we put the head in the sand and we continue and cross our fingers as if these risks do not exist. So this is a very good argument for action. And I would argue very strongly that this is starting to become understood. That's why I'm very optimistic, by the way, of what will happen in Paris, because this is sinking in, that we're kind of reaching a point of unacceptable risk, which we do not want to take. And the risk is so high because of these systems, because we're risking the stability of the large ice sheets that are melting so fast that they, of course, undermine livelihoods and undermine the ability for animals and plants, but particularly they change color of those big systems. You can see already from the graph here that you have this darker liquid surface when ice melts. Well, that is what scientists fear most, namely what we call changes in feedback. When the system goes from being a white permanent surface reflecting back 90% of heat back to space, to systems like that absorb more heat than they send back. That is self-reinforced warming, which we do not want to see. In fact, we know today that just the melting in Greenland in 2012 during 2 weeks added 200 exajoules of heat into the atmosphere. And that is, a third of the global energy use on the planet. So it just shows that these are big, big forces. We can now translate a 2-degree target to a global carbon budget. That's very good. It shows that we have a planetary boundary. We need to share a finite carbon budget. We can actually define that in numbers. We have roughly 900 billion tons of carbon dioxide remaining to emit if we want to have a reasonable chance to stay under 2 degrees. 900 divided by 40, which is what we're emitting per year today, gives us, another 20, 25 years in a fossil-run world economy. So we basically know from science that we need to have a zero-carbon world economy by 2050 if we're going to have a reasonable chance of staying in Eden. And that is a very, very clear target. It's a clear message, and it's a very positive message. On oceans, the same for climate. I just put this on the floor because I think it's important to recognize that we always talk warming. but climate change has this dramatic chemical challenge as well. This is the pH curve in the world's oceans over the past 25 million years, and just look at what pH has done since the Industrial Revolution. A 30% decline, an acidification of extraordinary speed. This comes only from one source, and that is carbon dioxide emissions from fossil fuel burning. It is simple high school chemistry. And carbon dioxide plus water becomes carbonic acid. And carbonic acid changes the calcium carbonate in the ocean and breaks it up, which are the building blocks for marine life. So from phytoplankton all the way to coral reefs get corroded by this acidification. Now what you see here in dark green is the pre-industrial level of calcium carbonate, the Lego blocks that build marine life on Earth. And as you see in the black dots here are all the coral reefs. There's not a coincidence that in the Holocene, coral reefs established themselves where there was a lot of Lego. Now this is the situation today, and this is the situation if we continue as usual. We're breaking down the calcium carbonate availability for marine life in the world's ocean. This is the chemical drama of the climate challenge. This is, by the way, by geoengineering will not work. Because if we just put mirrors in space and allow ourselves to continue to emit carbon dioxide, we might cool the planet, but we will break the oceans. So there is a lot of interactions with the biosphere. And I just want to close with this reminder that it's not only about reducing emission, it's really about being stewards of the living ecosystems. Because we've emitted through industrial emissions and through deforestation a staggering 545 billion tons of carbon since the Industrial Revolution. And that has led to roughly 0.85 degrees Celsius warming so far. But look here, the warming has only been contributed through the 240 billion tons of carbon dioxide that remain in the atmosphere. The other half, a little bit more than half in fact, are taken up by the oceans, acidifying them, and in forests. These are the world's largest subsidy to the world economy by far. Half of our emissions are hidden by the biosphere. This is resilience. This is an Earth system that wants to stay in the Holocene. The Earth is our best friend, but it will only remain our best friend if we do not only reduce emissions, but also keep natural ecosystems intact. That's why biodiversity is so important. We've put out something we call the Earth Statement to give business leaders and political leaders a guide towards a world that can stay within a safe operating space. And there's no surprise to you here. It's staying within 2 degrees Celsius and it's zero carbon by 2050. So you have scientific support for exactly the very, very ambitious plan that the Anthropocene has. We've been working with the World Business Council on something they call the Action 2020 to really translate a safe operating space in business. We're quite enthused from science that this is really, really eating itself into the business logic. I would argue it's no longer about protecting the environment, it's really about integrating it into the strategic business model. Europe is taking this seriously through the European Resource Efficiency Platform, putting out a very clear chart. Europe's competitiveness is about a transition to a resource-efficient and on the long-term circular economy, which really, really moves towards zero carbon emissions. Are we coming close then to, I'm coming close to the close, by the way. Are we coming close to a tipping point in terms of success? I would argue yes, the signs are very promising. I mean, when 550,000 people walked through Manhattan in the People's Climate March in September last year, that was, believe it or not, the world's largest single manifestation for any issue in modern history on Earth. Never before have so many people in the same day manifested for one issue as the climate march, which occurred in many cities around the world. That is a signal from the social system. But we also have other signals. When both Paris and when Beijing and other large cities, Santiago just a few days ago, start seeing the real costs of air pollution on health. 7 million people die due to air pollution-related disease in the world. These are issues that are increasingly being seen as unacceptable sidelines of a fossil fuel economy. 10 years back, we could say, well, but we have no choice. We can only alleviate poverty and have development if we have fossil fuels. Well, that is changing because we're now starting to see that innovation is coming to grid parity on energy, on technology, on materials, on mobility, that we simply not only have an environmental risk we need to deal with, not only do we actually have solutions, they can go to scale and they can create much more desirable futures. So I think the next generation started to see, a clean, more democratic, decarbonized future is really more attractive. And the urban challenge is at the heart of this. 2/3 of the cities we need by 2030 are not built yet. So of course you're sitting with the real card of solutions here. But I think the solution is not only about finding the policy measures, it's really about a mind shift. And the mind shift is that we still live in a logic where we have kind of growth without limits. We're still this small world on this big planet. We environmental scientists have tended to lock ourselves on a limits to growth agenda, creating quite a bit of rift between growth and development. I think we now have a new story. And this new story is really about growth within limits, about human prosperity within a safe operating space of a stable Earth system that remains in Eden. Thank you.
Thank you very much, Johan.